Hello everyone. Today we'll have an asynchronous learning. So this is a recorded video lesson in which you can open this using our Google Classroom. But before opening this lesson, this recorded video lesson, be sure you have answered already the pre-assessment given in the classroom. Okay, so today is a new week of learning. So you will learn 2 lessons from me. And I hope with last week's discussion about representing real-life situation using functions, you were able to get something from me. That whenever you are representing a situation using a function, we simply think of a formula that will fit in the given situation. Using piecewise function, we use 2 or more formula in which each formula has a set of domain. So to start with my discussion for this morning or this afternoon, let me share with you my PowerPoint presentation. So our lesson for today is all about evaluating functions. Yes, I know that you know already this topic, but we still need to recall this so that in the next lessons on functions, it will be easier for you since we have recalled already lessons which are related to functions. So at the end of this lesson, you are expected to recall the process of substitution, identify the various types of functions, and evaluate the function. Let me start by testing how do you still remember how to evaluate an expression. So this is entitled, What's the Value? So what's the value if x minus 9? What's the value of x minus 9 if x is equal to 3? So try to think of it by mental checking or mental substitution. You were able to determine, you will be able to determine the value of x minus 9 if x is equal to 3. And yes, you're correct. The value of that is negative 6. How did it happen? So simply substitute the value of x, which is equal to 3, from the given expression. So you will have 3 minus 9, and that is equal to negative 6. Very simple, isn't it? Let's have the second expression. So what's the value of x squared plus 4x minus 10 if x is equal to 3? Now this time, it's quite longer, but still, you can use mental computation. But if not, you may use your calculator. So what's the value? Let us try to substitute first the value of x, which is equal to 3. So doing that, the value will be 11. So how did it happen? So this is the way we solve that expression. So substituting x is equal to 3, then we will have 3 squared plus 4 times 3 minus 10. And since 3 squared means 3 times 3, multiplying 3 twice, we'll have 9. And 4 times 3 is equal to 12 minus 10. Performing the operations on these 3 numbers, then we have 11 as the value of the expression. Let's have the third expression. So what's the value of 5x to the 5th plus 4x to the 4th minus 3x cubed minus 2x squared plus x minus 7 if x is equal to 3? So this is quite longer. So I'll give you more time to compute for the value of this expression. So what's the value now? So the value is 1,436. How did it happen? Okay, so that's the way we substitute the value of x, which is equal to 3, from the given expression. So copy the 5, and when for the value of x, replace that with 3, raise that to the 5th power, plus 4, substitute again the value of x, which is 3, raised to the 4th power, minus 3, times the value again of x, which is 3, raised to the 3rd power, minus 2, substitute again the value of x, which is 3, raised to the 2nd power, plus the value of x, which is 3 again, minus 7. So for all those 3 with an exponent, you need to evaluate that first before performing the expression, or performing the operations on the expression. So finding the value of 3 to the 5th means multiplying 3 5 times. That's why we have 243. 3 to the 4th is 81. 3 cubed is 27. 3 squared is 9. So now that we have performed the exponents, we may now move on with multiplication. So with this expression, we use the PEMDAS rule. Okay? So multiplying 5 and 243, that is equal to 1,215. 4 times 81 is 324. 3 times 27 is 81. 2 times 9 is 18. Then copy plus 3 minus 7. Now, we may now perform the operations. So 1,215 plus 324 minus 81 minus 18 plus 3 minus 7 is equal to 1,436. So very easy, isn't it? Okay. So what do we mean by evaluating functions? So how do we do this? Before evaluating functions, let me share with you the different types of functions that you may encounter as we go along with our discussion for today. So here are the types of functions. First, we have a constant function. So from the name itself, you will just encounter, or the function only involve a constant. So generally, when we say constant function, it is in the form of f of x is equal to b, where b is a constant. So an example of that is y is equal to 7, or f of x is equal to negative 2. So those are examples of constant function. Second type of function is known as an identity function. Identity, the word identity itself means mirroring yourself. Okay? So an identity function is a function which returns the same value which was used as its argument. In other words, the identity function is a function in the form of f of x is equal to x. Whatever is the value of the one inside the parentheses, that is your function. So say we have f of 2 is equal to 2. F of 1001 is equal to 1001. So we have an identity function. The third type of function is a polynomial function. And this kind of function comes in 3 types. First, we have a linear function. As the name suggests, it is a function defined by a line. So generally, it is given in a form of y equals a raised to x plus a raised to the ax plus a squared, x squared, and so on and so forth. So to simplify that linear equation, we simply use y equals mx plus b for our linear function. So for the given example, we may have y equals 2x plus 5. Again, a linear function is a type of a polynomial function. The second type of polynomial function is a quadratic function. So quadratic if the degree of the polynomial function is 2. So how do we know that the degree of a function is 2? By simply looking at the highest exponent. So if the highest exponent is 2, then we have a quadratic function. So generally, a quadratic function is given in the form of y equals ax squared plus bx plus c. So as you can see, the highest exponent here is 2. So as an example, we have y equals 3x squared plus 2x plus 5, or another way of writing this is f of x equals 3x squared plus 2x plus 5. And the last type of polynomial function is known as the cubic function. So we have a cubic function if the degree of the function is 3. Okay, so or the highest exponent of the function is 3. So it is given in the form of f of x equals ax cubed plus bx squared plus cx plus d. As an example, we have y equals 5x cubed minus 7x squared plus x minus 11. So again, the third type of function is a polynomial function, which comes in 3 types. We have the linear function if the degree is 1, cubic function if the degree is 2, and rather the quadratic function if the degree is 2, and the cubic function if the degree is 3. Okay, so we have 3 types of functions already: the identity, the constant, and the polynomial. And as we continue, we have now the power function. When we say power function, it is a function in the form of y equals ax raised to b, where b is any real constant number. So many of our parent functions, such as linear functions and quadratic functions, are in fact power functions because they involve exponents. So as you can see, as you have seen in the examples given in the polynomial functions, when it comes to quadratic, we have the term 2x squared, and that is already a power function. So with this, our example given here is f of x is equal to 8x raised to the 7th power. The next type of function is known as the rational function. A rational function is any function which can be represented by a rational function or a rational fraction. You know that a rational fraction is any fraction which can be expressed as a quotient of 2 terms. So generally, a rational function is represented by f of x equals p of x over q of x. As our example, f of x is equal to x squared minus 3x plus 1 over x squared minus 4. Next type of function is known as the exponential function. So using exponential function, we have the form y is equal to ab raised to the x power, where x is an exponent and a and b are constants. So please take note that only b is raised to the x power and not anymore a. So if the base b is greater than 1, then the result is exponential growth. Otherwise, it is an exponential decay. So as for our example, we have f of x is equal to 2 raised to the x power. Next function, we have the logarithmic function. So this is a function, or a logarithmic function is just the inverse of an exponential function. And any exponential function can be expressed in logarithmic function and vice versa. Okay? So logarithmic function is given in the form of y is equal to the logarithm of x to the base b. So as for our example, y is equal to the logarithm of 49 to the base 7. The last two types of functions are absolute value function, meaning it is a function that makes use of the absolute value symbol. Remember that when we talk of absolute value, any number, whether that is positive or negative, the value will always be positive. So generally, an absolute value function is written in the form of f of x is equal to the absolute value of x. So any function that involves absolute value is an absolute value function. So as for our example, we have y equals the absolute value of x minus 4 plus 2. So please take note that only the expression x minus 4 is inside the absolute value symbol. The last type of function is known as the greatest integer function. Greatest integer. Remember that when we say integer, these are whole numbers, positive whole numbers, and negative natural numbers. No decimals, no fractions. So generally, it is in the form of f of x equals the greatest integer of x. So please take note of the symbol. And then for our example, we have the 2 bars before x and 2 bars again after x, meaning you need to find its greatest integer value plus 1. So now that you know the different types of functions, we may now start evaluating a function. So when we say evaluating functions, it is actually a process of determining the value of the function at the number assigned to a given variable. So just like the first activity that we had, finding the value of an expression. So evaluating functions means finding the value of the function given a value of the variable. So take a look on these examples. P of x is equal to 3x squared plus 5x minus 2. Find the value of the function given that p is equal to 0 or x is equal to 0 and x is equal to negative 1. So we need to find the value of the function for p of 0 and p of negative 1. So let's start with p of 0. So we need to substitute 0 from the given function. So we will have p of 0 is equal to 3x squared plus 5x minus 2, which is the original function. Now replace all the x's by 0. So we have 3 times 0 raised to the second power plus 5 times 0 minus 2. You know that any number multiplied by 0 is equal to 0. That's why p of 0 is equal to negative 2. How about when x is equal to negative 1? So finding the value of the function for p of negative 1, we will have, using the same function, which is 3x squared plus 5x minus 2. Again, replace all the x's by negative 1. And then let's try to find the value of negative 1 raised to the second power, and that is equal to positive 1. While 5 times negative 1 is equal to negative 5, and then copying negative 2. So 3 minus 5 minus 2 is equal to negative 4. Therefore, the value of the function for p of 0 is negative 2 and p of negative 1 is negative 4. Let's have another example. So this particular example is an example of, yes, you're correct. It's a rational function. So h of x is equal to 4x plus 8 over 2x minus 4. Find the value of the function if x is equal to negative 5. Again, very easy. Using the original function, which is 4x plus 8 over 2x minus 4, to find h of negative 5, simply substitute or replace x with negative 5. So we have 4 times negative 5 plus 8 over 2 times negative 5 minus 4. So multiply first 4 and negative 5, and that is equal to negative 20 plus 8 over multiply 2 and negative 5, and that is equal to negative 10 minus 4. Simplify each part of the fraction. So negative 20 plus 8 is negative 12, and negative 10 minus 4 is negative 14. So we have negative 12 over negative 14. And lastly, to find the value of h of negative 5, we need to simplify negative 12 over negative 14. Thus, we have the value of h of negative 5 is equal to 6 over 7. Actually, in solving or in evaluating functions, you can use your calculator, of course. Anytime, you may use your calculator. So let me now proceed with the third example. This third example is an example of, yes, it's an exponential function. So given that f of x is equal to 2 raised to x, find its value if x is equal to 3 over 2. So f of 3 over 2 is equal to 2 raised to x, which is the original function. And replacing x by 3 over 2, so we have 2 raised to 3 halves. So we have a fractional exponent. And any expression with a fractional exponent can be written as a radical expression. So how do we do that? The numerator becomes the exponent of the base, and the denominator becomes the index of the radical expression. Thus, rewriting that as a radical expression, we have the square root of 2 raised to the third power. And what's the value of 2 raised to the third power? Yes, you're correct. It becomes the square root of 8. So how do we find the square root of 8? 8 is not a perfect square, so we need to express 8 as 2 factors in which one of its factors is a perfect square. Thus, we will have the square root of 4 times 2. Then you know that the square root of 4 is equal to 2. So extracting that, we have f of 3 halves is equal to 2 square root of 2, or 2 times the square root of 2 for the value of f of 3 halves. I hope you were able to recall radical expressions. So I will not discuss much on that. Next example. Okay, as you can see, with the symbol used, it's a greatest integer function. So with the last example, we have evaluate the function h of x, which is equal to the greatest value of the integer x plus 2, where x is the greatest integer function given x is equal to 2.4. So let us solve. H of 2.4 is equal to the greatest integer 2.4 plus 2. You need to find the greatest integer for 2.4. And the greatest integer, again, as I have said a while ago, no decimals, no fractions. So what's the greatest integer from the given value of x? Yes, that is 2. That's why h of 2.4 is equal to 2 because that is the greatest integer for 2.4, then the plus 2. Therefore, h of 2.4 is equal to 4. Very simple, isn't it? Any question when it comes to evaluating functions? I hope you find it easy how to evaluate functions. I still have here another example. Evaluate the function f of x equals the absolute value of x minus 8, where the absolute value of x minus 8 means the absolute value of x minus 8 if x is equal to 3. So simply substitute the value of x, which is 3. So we have f of 3 equals the absolute value of 3 minus 8. 3 minus 8 is equal to negative 5, and finding the absolute value of negative 5, so we have f of 3 is equal to 5. So sorry for the typographical error. Again, that is equal to 5 and not negative 5. Next, we have evaluate the function f of x is equal to x squared minus 2x plus 2 at f of 2x minus 3. So this time, the value of x given is not a constant. So how do we do this? It's the same. Just replace the x, all the x's, by 2x minus 3. So from the original function to find f of 2x minus 3, replace x, the first x, by 2x minus 3. Since it has an exponent of 2, then you need to raise 2x minus 3 to the second power. Minus 2, then replace again the x by 2x minus 3, then plus 2. So with our first expression, we need to multiply 2x minus 3 twice. And doing that, you need to recall the process or the method of using the FOIL method, because you will now be multiplying two binomials. Or if you can still remember the short way of doing that, you only need 3 steps. First, you need to take the square of 2x. So 2x times 2x is equal to 4x squared. Then, multiply the exponent 2 outside to your first and second terms. So 2 times 2x is 4x times negative 3 is negative 12x. And that will be your second term of the expression. And last step is you need to take the square of the last term of the binomial, which is negative 3. So negative 3 times negative 3 is positive 9. And with the second term of the expression, you need to multiply negative 2 to 2x and to negative 3 respectively. And then with the last one, just copy it. So you will have 4x squared minus 12x plus 9 as the value of raising 2x minus 3 to the second power and multiplying negative 2 to the term inside the parentheses, we have negative 4x plus 6, then plus 2. So with this one, we need to combine similar terms. And the similar terms are negative 12x and negative 4x, and then all the constants. Thus, we have f of 2x minus 3 is equal to 4x squared minus 16x plus 17. So that's how we evaluate a function given the value of the variable as an expression and not just a constant. So this time, we will proceed with our second lesson. This is actually a third lesson under functions. So with our module 1, that is all about functions, the first lesson is representing real-life situations using functions, which was discussed last week. And today, you have evaluating a function, and the lesson 3 is operations on functions. Yes, you're correct. When we talk of operations, it involve addition, subtraction, multiplication, and division. But in the case of functions, it does not involve only, the operation does not involve only the 4 operations. So you will learn an additional operation later. So at the end of this particular lesson, you're expected to define operations on functions, identify the different operations on functions, and perform addition, subtraction, multiplication, division, and composition of functions. So that's an additional operation. So let us first define the operations on functions. So let f and g be functions. So f plus g of x is equal to f of x plus g of x. Meaning to say, if you are asked to find the sum of two functions, f and g, we simply find the sum of the given functions. For subtraction, for the operation on subtraction, f minus g of x is equal to f of x minus g of x. So their difference is denoted by f minus g. If you want to find the product of these two functions, so that is denoted by f, then our symbol for multiplication, which is a small dot, g, so f times g of x is equal to f of x times g of x. So very simple, isn't it? Then for the division, we have f over g of x is equal to f of x over g of x. So their quotient is denoted by f over g. And the last one is the notation for the composite function. So that is denoted by the composite of f and g of x is equal to f of g of x. So the process of obtaining a composite function is called function composition. So let's have examples. So given the functions f of x equals x plus 5, g of x 2x minus 1, and h of x is 2x squared plus 9x minus 5. Determine the following functions. So the first involves A and E involves addition, B and F involves subtraction, C and G multiplication, D and H division. So let's perform now. So finding the sum of the two functions, we have f plus g of x is equal to f of x plus g of x, which is the original definition of addition of the two functions. So let's substitute or replace f of x by x plus 5 and g of x by 2x minus 1. Then simplify. By combining similar terms, x plus 2x is equal to 3x and 5 minus 1 is 4. Therefore, f plus g of x is equal to 3x plus 4. Very simple. Next, to find the difference between the two functions, we have f minus g of x is equal to f of x minus g of x. That is based on its definition. Then replace again f of x, which is x plus 5, then minus the value of g of x, which is 2x minus 1. So it's very important that when you replace the second function, since it is preceded by a minus sign, you need to enclose that by a negative sign, by a parenthesis rather. And then, you may now remove the parentheses. So no problem with the first expression. X plus 5 will still be x plus 5. But with the second expression, since it is preceded by a minus sign, you need to change the sign of all the terms inside the parentheses. So removing the parentheses, you will now have, for 2x, it will now be negative 2x, and for negative 1 will be positive 1. That is actually the same as multiplying negative 1 to the terms inside the parentheses. Thus, f minus g of x is equal to negative x plus 6. Why? Combining x and negative 2x is negative x, and 5 plus 1 is positive 6. Now let's have multiplication. So f times g of x is equal to f of x times g of x. Again, that's the definition. Then replace the value of f of x and g of x respectively. So we have x plus 5 times 2x minus 1. So we need to recall again how to multiply or to find the product of two binomials. So performing FOIL method, thus f times g of x is equal to 2x squared plus 9x minus 5. Again, for doing the FOIL method, you need to multiply x times 2x for the first terms, and that is equal to 2x squared. Then outside, we have x times negative 1 is negative x. Then 5 times 2x is 10x. So simplifying that, 10x minus x is equal to 9x. Then for the last term, 5 times negative 1 is negative 5. That's why we have 2x squared plus 9x minus 5. Let's have letter D, the quotient of two functions. H of g of x is equal to h of x over g of x. Again, that is the definition. Now replace h of x. So from the given, the value of h of x is 2x squared plus 9x minus 5 over 2x minus 1. So we need to simplify this. Actually, this is part of your grade 8 math. You need to factor your numerator. So it's a matter of trial and error since it's not a perfect square trinomials. So find the factors of 2x squared. We have x and 2x for the first term of the binomials. Then, the factors of negative 5, it can be 5 and negative 1. It can be negative 5 and positive 1. So it's a matter of trial and error method. Okay? You need to check whether your middle term will be equal to 9x. So as you can see here, the factors now of 2x squared plus 9x minus 5 are x plus 5 and 2x minus 1. Then, with the same denominator of 2x minus 1. So simplifying this, we can cancel 2x minus 1 from our numerator and 2x minus 1 from our denominator. Thus, h of g of x is equal to x plus 5. Let's have example E. That is actually almost the same with letter A. The only difference is that, of course, you need to replace the variable x by a constant value, which is 3. So, f plus g of 3 is equal to f of 3 plus g of 3. So, replacing f of x, which is x plus 5. So, replacing the x there by 3. Thus, we have 3 plus 5. And the expression for g of x, which is 2x minus 1. So we have 2 times 3 is 6, minus 1 is 5. So combining 8 and 5, then we have f plus g of 3 is equal to 13. Let's have example F, which is similar to example B. So just replace the variable x by 3. So to find the difference between the two functions, f minus g of 3 is equal to f of 3 minus g of 3. So x plus 5 as our f of x. So we have 3 plus 5 is 8. And then for the value of the second function, which is 5, so since the operation is subtraction, so we have 8 minus 5 is equal to 3. Therefore, f minus g of 3 is equal to 3. Very easy. Everything in math is easy. Let's have example G. So multiplication of two functions. So from the definition, to find f times g of 3 is equal to f of 3 times g of 3. So replace again the x from in the x plus 5 expression as well as in 2x minus 1. So 3 plus 5 is 8. Then the value of 2x minus 1 when x is equal to 3 is 5. So multiplying 8 and 5, so f times g of 3 is equal to 40. Let's have division. H of g of 3 is equal to h of 3 over g of 3. Okay, no need of factoring because the value of x is a constant. So from the expression or from the value of the h function, replace all the x's by 3. Then for the value of the g function, which is 2x minus 1, replace again x by 3. So simplifying that, we have 2 times 9 plus 9 times 3 minus 5 over 6 minus 1. So 2 times 9 is 18 plus the product of 9 and 3, which is 27, minus 5. Then simplifying the denominator, we have 5. Combining all the terms in your numerator, we have 40 over 5. And simplifying the fraction, we have 8. Thus, h of g of 3 is equal to 8. Now, this time, let's have the composition of functions. Given the functions f of x equals x squared plus 5x plus 6 and h of x as x plus 2, find the following. The composition of f and h of x, then b, the composition of f and h of 4, and lastly, the composition or the composite function of h and f of x. So how do we do that? So for the composite function of f of h of x, we already know that when we say composition of a function, it is a function within a function. Okay? So you need to integrate the function the function h of x to the function f of x. So again, when performing operations on two or more functions, the result is a new function. So for addition, subtraction, multiplication, and division, as you can see with the examples, we have a new function. So in the case of composition of functions, this will entail a lot of substitution. So look at this first example. F of h of x. So what's the value of h of x again? Yes, that's x plus 2. So we have f of x plus 2. And since f of x is equal to x squared plus 5x plus 6, we need to replace all the x's by the value of h of x, which is x plus 2. So doing that, we have the quantity x plus 2 raised to the second power plus 5 times the quantity x plus 2 plus 6. So raising x plus 2 to the second power, we have x squared plus 4x plus 4. Again, recalling the way of doing that, you need to square x. So x times x is x squared. Then the 2 outside, the exponent 2 outside must be multiplied to x and 2. So 2 times x is 2x times 2. That's why we have 4x. Then squaring the second term of the binomial, 2 times 2 is 4. Then for the second expression, need to multiply 5 with x, same with 2. So 5 times x is 5x, then 5 times 2 is 10, then plus 6. So simplifying this expression, thus we have for the composite function of f and h of x is equal to x squared plus 9x plus 20. So there are two substitutions actually. Let's have the second one. F of h of 4, or the composite function of f and h of 4 is equal to f of h of 4. So from the previous example, we know already that the value of f of h of x is equal to x squared plus 9x plus 20. So we need only to substitute the value of the given x for h of h, which is 4. Thus, we have f of h of x is equal to x squared plus 9x plus 20. Replace all the x's by 4. So we have 4 squared plus 9 times 4 plus 20. So evaluating 4 squared, that is equal to 16, plus the product of 9 and 4, which is 36, plus 20. Thus, the composite function of f and h of 4 is equal to 72. Last example. The composite function of h and f of x. So this time, f and h reverse in terms of its order. So that is equal to h of f of x based on the definition. So what's the value of f of x? So that is x squared plus 5x plus 6. So since h of x is equal to x plus 2, we need to replace the variable x by the value of f of x, which is x squared plus 5x plus 6. Thus, we have h of x squared plus 5x plus 6 is equal to, the first term is x. So replace that by x squared plus 5x plus 6. And the second term is 2. So again, the first three terms, x squared plus 5x plus 6, comes from the value of f of x. Then simplify. We just need to combine the two constants. Thus, the composite function of h and f of x is equal to x squared plus 5x plus 8. So generally, performing composition of function is not the same as what we did on the first four operations on functions. So composition of functions only means that order of functions counts in the composition of function operation. So there are special cases where they will be the same. This is when the two functions are inverse. So graphing and finding the domain and range of algebraic operations is not covered on this particular lesson. So you will learn on the inverse of functions on probably 2 to 3 more weeks pa. Okay? So if you have no more questions, that will be the end of my presentation. And it's now time for you to answer the assessment given again in the Google Classroom, and kindly open the module uploaded also in the Google Classroom, because there are parts there where you need to exercise yourself by solving learning task number 2, number 3, and then answering learning task number 4. Again, all the tasks given in the module only are due on Friday, October 16, 2020 at 5 p.m. But with the pre-assessment and the assessment, or the pre-assessment must be answered before playing this recorded video lesson, and the assessment is of course after hearing these 2 lessons. So goodbye everyone, and hope you learned something from me. Thank you.